Bismillahirrahmanirrahim. Today we will learn the partial fractions of such type of fractions in which denominator contains non-repeated irreducible quadratic factors and linear factors. So the linear factors are the factors which contain the power of the variable as 1, like in this example x raised to power 1 is there, and we have another factor that will be quadratic, means the highest power of the x will be 2, and those would not be able to factorized, means that those will not be reducible to linears. So that's why it is prominently written that factors will be irreducible quadratic factors. We will learn that how to make the partial fraction of these type of fractions. So one thing that you have to make sure that obviously the partial fractions can only be formed if the entire fraction is in the form of proper fraction. So we will start the exercise 4.3 and its first question, that is 3x minus 1 over x plus 1 and x square plus 1. So let's begin that how to find the solution of such type of equations. So we will start the fractions by writing starting from the very first line. We will first write a over x plus 3 plus quadratic part of the denominator, and whenever we would write the quadratic term in the denominator, we will write it as bx plus c form. This is all because of there is a quadratic term involved in it. Now, rest of the procedure is same as we have done in the previous exercises, that we will first take up the LCM. And the LCM will be x plus 3, x square plus 1. LCM will become a times x square plus 1 bx plus c into x plus 3. The term on the left hand side will be as usual, means it will be written as it is. Now once we have taken the LCM, we will cancel out these terms from both sides, and we will form an equation that is labeled as, let's suppose, equation number 1. So as it is, it will be written, just LCMs will be cancelled, and we will rename it, for example, equation number 1. Now to find the value of ABC, we will first find the value of the linear factor, that is x plus 3, we will put it equals to 0, and from here we will derive the value of x, that is minus 3, and we will put this value in equation 1. We have just formed above equation number 1. So once we will start substituting the value, that is minus 3, where there is x, substitute minus 3. Where there is minus 3b plus c minus 3 plus 2. A times 9 plus 1, and it is this whole portion will become 0. This will become minus 9 minus 11, that is minus 20. A into 10. So consequently, you will be getting the value of A, that is equals to minus 20 by 10. This is equals to minus 2. So we have calculated the value of A alphabet. Now for finding the value of B and C, we need to expand equation number 1, because we don't have any other linear factor to put or to equate put it to equals to 0. So that's why we need to multiply the entire equation on left hand side and on right hand side as well. Simply multiply equation number 1. This is the work is being done on an equation number 1. Get the terms multiplied. Cx plus 3. So this is the working I am doing with on equation number 1. Both will be multiplied, a's will be multiplied, and now you need to separate the variable x square first and take out x square as common. The remaining will be a plus b. Then take x common. It will be 3b plus c, and a plus 3c. On left hand side we have 3x minus 11, right? So because we don't have any term involving x square, we simply can place it like 0x square, so that we can simply compare comparing coefficients of x square, x, and constants on both sides. So first comparison, 0 will be compared with a plus b, 3 will be compared to 3b plus c, and minus 11 will be compared to a plus 3c to make three equations. First will be a plus b equals to 0. We suppose this is equation number 2. Then we form 3b plus c, that is equals to 3. This is third equation. And a plus 3c is equals to minus 11. This is equation number 4. Now, as we have already calculated the value of a above, so we can simply derive the value of b, that is b is equals to minus a. So it would become plus 2. This is how we will be able to get value of b. Now we need the value of c. So if we do the working right in front of equation number 3, that states c is equals to 3 minus 3b. So putting the value of b now, just calculated above, it will become c is equals to 3 minus 6 minus 3. Now, ABCs are calculated. We will go back to the question. That was the very first line. We will substitute the calculated values of A, B, and C to finish the question. So we will rewrite the question. That is 3x plus, this is the first equation. So at this stage, we will rewrite the question again. And in this equation, we will substitute the values of A, B, C, which are just calculated. So A is equals to minus 2. So we will put it right here. Minus 2 over x plus 3. B is plus 2. So 2x, in place of B, we will substitute the value of 2. In place of C, this is minus 3. And this is how the question will be completed. On left hand side, this is 3x minus 11 over x plus 3, x square plus 1. So it is the answer of partial fractions for question number 1, complete solution. Once the values are substituted, it will be like minus 3 square plus 4. In place of x, we will substitute minus 3b plus c minus 3 and plus 3. So simplifications will give us 9 plus 4, and this part will become 0, minus 9 plus 7 minus 2, and this will be 13a. So from here we will derive the value of a, that is minus 2 over 13. So one value is calculated. Now we don't have any other linear factor to put, so we will have to multiply the equation number 1 on right hand side. In other words, we will expand equation number 1 to make further equations in terms of a and b. So simply multiply equation number 1, bx square plus 3bx plus cx plus 3c. Now take out common first the variable x square, that is a plus b. Then take out x common, 3b plus c plus 4a plus 3c. Now comparing coefficients on both sides. Comparing coefficients comparing coefficients of x square, x, and constants on both sides. So once we will compare, because we don't have x square on left hand side, you can write at 0 x square and then compare coefficient of x square on both sides. So it will be your, you can say, equation number 2, because we already marked equation number 1 above. So that's why 3b plus c will be compared to coefficient of x on left hand side, that is 3. This would be the third equation. And finally we will have 4a plus 3c equals to 7. These are the constant terms, the comparison of constant terms. We have already calculated a. So again from equation number 2, we will get the value of b, that would be equals to minus a, and a is written above in the box. Simply substituting the value, it will become 2 over 13. Now we need to find value of c, that can be calculated right from equation number 3 easily. That is c is equals to 3 minus 3b. So value of b is just calculated above. B will be 2 over 13. C is equals to 3 minus 6 over 13. So this is 39 minus 6, 33 over 13. So now C will become 33 over 13. This is value of C. Now we will substitute the value of calculated values of ABC in the very first line of the question to finish the value. So the important step right here is it is a statement of the question. We would paste it right here. Values of ABC. Now we have to be very careful while finalizing the answer, first we will substitute the value of A, B, C. So A is minus 2 over 13. Substitute it right here. 2 over 13. B is plus 2 over 13. And C is 33 over 13. So in first step, we will substitute the value of A, B, C. Then we do need to further simplify it. How to simplify that? This 13 will become in the denominator. And we will have to take up one LCM in the denominator above. That is 13. 1x was also been there. So take up the LCM right here. It will become 2x minus 33. And denominator will contain x square plus 4. Now one more, because we have taken the LCM, now shift this 13 2 in the denominator in the next step. So this would become 2x minus 33 over 13 times x square plus 4. And on left hand side we have 3x plus 7, the original statement of the question. And this is how we will finally obtain our answer. These are the lengthy questions, not short questions.